Polymers made from petrochemicals by Courtney Lambert.
Polyethylene, polystyrene, and polypropylene are the three main polymers made from petrochemicals.
While polystyrene, polyethylene, and polypropylene may be the most common forms of plastic, there are indeed multiple others, around 45 different types of plastics in total. Some of the more common ones are PVC, polyvinyl chloride, polyacrylamide, PVA, polyvinyl acetate, polytetrafluorethane, or PTFE, otherwise known as Teflon. Polymers in general have been commonplace since the end of World War II, when they were used excessively as plastic casing fibers and rubbers. Polymers in the form of plastics were first discovered in 1862 by Alexander Parks. Polystyrene was discovered in 1839 by German pharmacist Edward Salmon, but was useless as he could not create a pure form. This is why Alexander Parks is listed as the first discoverer of plastics. In 1937, Robert Dispatch purified styrene, and by 1988 it was being used commercially. Polypropylene was polymerized in 1954 by Giulio Nato using a method created by Carl Zenger, and the two shared a Nobel Prize for Chemistry in 1963 for their discovery. Polyethylene. Polyethylene is produced through the process of cracking, used to make ethylene from ethane as it is heated to 850 degrees Celsius, separating the hydrogens and causing the carbons to form a double bond. Polymerization then occurs, causing the double bond to break instead of bonding with another carbon. This changes states from a gas to a solid and forms a powder. Low-density polyethylene is a form of PE that has a low tensile strength and is flexible, but with low heat resistance, melting at 115 degrees. It is clear and is used for Glad wrap and sandwich bags. On the other hand, high-density polyethylene's examples come in both of its form. In low-density polyethylene is used for stuff such as milk bottles, soft toys, and cling wrap, whereas high-density polyethylene is used to make more solid, less flexible items such as rubbish bins, suitcases, containers, rigid toys, kitchen utensils, and carry-on bags. Polyethylene has a high tensile strength and a high melting point of 135 degrees. This is a rigid and semi-clear consistency and is used for cables and water pipes, among other purposes. Styrene is produced when ethylene is reacted with benzene to produce ethylbenzene, which is then dehydrated to make phenylstyrene, commonly known as styrene. This is then polymerized to make polystyrene. Polystyrene is hard and rigid and less expanded to contain air. It then becomes useful for foam bowls and packaging. Polystyrene can be used not only in its expanded form, but also in its unexpanded form to form clear, visible, flexible plastic that's used in items such as CD cases, straws, modern furniture, tool handles, disposable drink cups, plastic cutlery, car battery cases, plastic plates, and then it's an expanded form, foam packaging, and foam cutlery. The expanded form consists, however, of 95% gas, and so actually contains minimal polystyrene. Propylene. Polypropylene, or propene, is one of the byproducts of cracking in naphtha and is one of many. Its chemical symbol is 3 carbon and 6 hydrogen, and like all other monomers has a double bond. It is then polymerized using a catalyst and forms polypropylene. Polypropylene has a 45.1 million ton global market that converts to $65 billion. It is flexible and resistant, as well as heat resistant and lightweight, making it ideal for usage as hundreds of things. It is used in toys and loudspeakers, as well as containers. Propylene also has many other uses, including as containers, piping systems, packaging, cable insulation, disposable bottles, folders, ropes, carpets, water bottle lids, use in technology, specifically the plastics of it, lab equipment, roofing membranes. All these things use plastic within them, and most of them use polypropylene. Environmental and social impacts. Polystyrene is classified as a non-recyclable as it is expanded form 95% air and absorbs oils. This means in order for it to be recycled, it must be cleaned of any mold or stain before only giving 1/40th of the original size. This is highly expensive and as such makes it unrealistic. This is why many cities are beginning to ban the use of styrene as it is non-biodegradable, expensive to recycle, and its creation produces greenhouse emissions.